All right, so we're diving into ThinkPython today. Flicking through it, I gotta say, even for someone who's, coded a bit, this stuff is pretty thought-provoking. What do you think? Ready to think like a computer scientist for a bit?
Definitely. The way ThinkPython blends math, engineering, and science right off the bat is interesting. Like, that's the heart of computer science.
Yeah, it really is, and it doesn't waste time. You're practically coding before you even know what a Python interpreter is. It even just throws the Python 2 versus 3 thing out there.
The whole philosophy seems to be learn by doing, even if it means messing up. Like, it encourages you to try code that's wrong just to see the errors. I guess the idea is you kind of got to push the boundaries to understand them. It's like that time I tried to, well, let's just say I learned a lot about memory allocation the hard way that day.
Uh-huh, okay. Pushing boundaries, got it. But what about all the precise stuff, like values and types? The book's big on using type to figure out if something's an integer or a float or a string, but then it throws that curveball with commas in numbers. Who knew typing 1,000,000 would make a sequence, not a number?
Yeah, that gets people all the time,
Yeah.
but it shows how precise you got to be. Unlike, just talking, programming languages are super literal. That one comma changes everything to Python. It's like, have you ever baked something and used salt instead of sugar by mistake?
Yeah. One tiny error and it's ruined.
Exactly.
So attention to detail is huge, though I will say the way the book compares formal programming languages to how we normally speak is interesting. It's like poetry versus a set of instructions. Poetry's for feeling, but code has got to be exact to work.
Right. Take a simple instruction, like add the numbers from 1 to 10. Easy in English. But in Python, you need loops, variables, the whole 9 yards. Every symbol matters. It's almost like putting together a machine where every piece has its exact spot.
Which brings us to functions, those building blocks from chapter 3. From simple ones like print lyrics to more complex ones. I'm sensing a theme here. Building blocks, machines. Are we about to play with Legos?
Well, the analogy works. Functions are basically reusable chunks of code. Like, we're making our own tools to use later for bigger tasks. And then there's how Python actually runs this code. It's line by line, like following a recipe, except when we hit a function call.
Then it's stack time, right? Those diagrams were confusing at first, but they make sense once you get the hang of it. Like each function call opens a new level and we got to track where we are.
And that's where debugging comes in. I think Python is big on this from the start. Syntax errors, runtime errors, even those sneaky semantic ones where the code runs, but it's doing the wrong thing. Knowing the different types helps you figure out where the problem might be. It's like a doctor figuring out what's wrong based on your symptoms.
Right, so debugging is our programmer's first aid kit. Any favorite techniques from the book?
They cover the basics, like using print statements to see what your variables are doing. But honestly, sometimes the best thing is just explaining your code out loud like you're teaching it to someone. Forces you to slow down, and that often reveals the problem.
Interesting. So talking it out, even if it's to like a rubber duck, is a legit strategy.
Totally. And speaking of things that seem weird at first, have you gotten to the part about recursion yet? Functions calling themselves, it's like magic. But if you get it right, the solutions are so elegant.
It's on my list. That's the countdown example, right? Where the function keeps calling itself until it hits 0.
Yeah, that's one. And it also brings up fruitful functions, those that actually return a value, like the distance example for, well, calculated distance. You start to see the focus on efficiency there.
Efficiency. Now that's something I'm always working on. Encode A&D in life, haha.
Well, think Python doesn't just tell you to be efficient. It shows you how. Even with something simple like distance, it goes through multiple ways to do it, each one getting smoother.
So it's not just getting the right answer, it's about doing it in the most elegant way.
Exactly. That attention to detail, finding the best solution, that's what separates the good programmers from the great ones.
Okay, I'm feeling inspired to step up my game. Where to next in this deep dive?
Let's tackle another biggie, iteration. Those loops we talked about is a whole chapter, and it's not just about repeating tasks, like a fundamental problem-solving thing.
Tell me more.
Think of those guess the number games. You guess, you get feedback, you adjust. Loops are how we do that in code. We're telling the computer to keep refining its answer until it's close enough.
So it's not mindless repetition, it's teaching the computer to learn.
Exactly. And that idea of getting closer and closer, it's powerful stuff.
Amazing. All right, loops it is.
That whole iterative approach, it pops up in so many algorithms. It's cool how much of programming is just solid problem solving.
It really is. So we've got these loops going, but then the book's like, hold on, strings aren't just text in Python. They're sequences of characters, and that changes everything.
It's like Instead of Lego bricks, now we've got the individual Lego pieces. We can rearrange them, swap them out, all kinds of stuff.
There's that funny example where you combine JKLMNOPQ with ACK and get, well, words. Kind of silly, but it shows what you can do with strings.
That's what I like about ThinkPython.
Mm.
It's playful, but the concepts are powerful. Like even simple string methods, upper and lower,
Yeah.
they're building blocks for stuff like text analysis, the real deal.
Right, so it's not just word games, it's practical stuff.
Exactly. And then we hit lists. Those are like the mega containers. They can hold anything, numbers, strings, even other lists.
They're like that junk drawer we all have, but way more organized.
Yeah. And just like with strings, you've got tons of tools to mess with lists, adding things, removing them, sorting, the whole 9 yards.
But isn't there a catch? Something about aliasing and how it can mess things up when you're changing lists?
Good catch. Aliasing is when 2 variables end up pointing to the same thing. It's like having 2 labels on one box. Change it with one label and the label sees the change too. Can cause some nasty bugs.
So how do you avoid that? What does the book say?
It's all about understanding how functions get their info. When you pass a list to a function, you're not actually passing a copy. You're passing, like, directions to where that list lives.
So if the function changes the list, the original outside has changed too.
That's the danger. That's why ThinkPython brings up deep copy. It makes a truly separate copy so you can tinker without breaking the original. It's like hitting duplicate on that box so you've got 2 to work with.
Gotcha. So strings, lists, and how to not break them. What else does ThinkPython have for us?
Dictionaries. These are all about speed, finding things fast. Imagine a giant, perfectly organized warehouse.
So not a junk drawer, but everything labeled and in its spot.
Exactly. Every item has a key, like the label, and a value. What's inside? Know the key, bam, you get the value instantly.
A perfect filing system for data.
That's the power of dictionaries. ThinkPython shows how to use them for, like, counting words in text or mapping relationships between things.
It's kind of like Boolean functions, right? You ask a question, they give you a yes or no answer based on some condition.
Good connection. Booleans are crucial for decision-making in code. Like, if this, then that. It's how your program figures out what to do based on what's true or false.
It's like those choose-your-own-adventure books, but for code.
Spot on. You're making decisions based on what happened before, guiding the whole flow of the program.
Boolean functions, got it. Dictionaries, got it. Anything else up ThinkPython's sleeve?
Okay, ready for a mind bender? Recursion. Remember how we talked about functions calling themselves?
Yeah, it was a bit like a snake eating its own tail.
I love that image. Recursion is tough to grasp, but super powerful, especially for problems that kind of repeat their own pattern.
Repeat their own pattern. Like, what do you mean?
Think of a tree. It has a trunk, then branches, then smaller branches. The same pattern over and over. Recursion is how we code that.
Ugh, like those Russian nesting dolls. Each one has a smaller one inside.
Perfect. Each call is like opening a new doll. You keep going till you hit the smallest one, the base case. Then you work your way back out.
And if you don't have that base case, you're stuck in a loop forever. Like one of those funhouse mirror hallways that never ends.
Exactly. Recursion's powerful, but gotta be careful. ThinkPython has that classic factorial calculation example.
Factorials. Love doing those by hand. Not...
Well, recursion makes it way easier, and it shows how you can take a big problem and break it down into smaller, similar ones.
Okay, I see the appeal, even if it makes my brain hurt a bit. What other coding wizardry does ThinkPython have?
Let's shift gears to tuples. They're kind of like lists, but with a twist. Imagine a list that's, well, set in stone.
Set in stone, like you can't change it once it's made.
Exactly. Tuples are immutable. Once they're defined, that's it. Might seem limiting, but that makes them super efficient in some cases. For one, they're faster than lists sometimes, and they're safer. If you know some data shouldn't be changed, a tuple guarantees that.
So if lists are like playful puppies, tuples are those wise old tortoises, slow and steady, but you can rely on them.
Love that. You got it.
Yeah.
Now, check out tuple assignment. It's like assigning values to multiple variables all at once.
So instead of writing name equals Alice and then age equals 30 on separate lines.
You do it all in one go.
Mm-hmm.
Name, age, Alice 30. It's small, but your code looks way cleaner.
Plus, it feels kind of magical.
Right. And it's more useful than you'd think. Swapping values, working through lists of tuples, even returning multiple things from a function.
Tuple assignment is going on my must-use list.
Good choice. Okay, let's talk about organizing our code. Modules.
Those are like the specialized toolboxes, right? Each one for a specific job.
You got it. Python comes loaded with modules, and ThinkPython shows you the good ones. Math, dates and times, random numbers, all kinds of stuff.
It's like having a team of coding experts on call.
Exactly. And get this, you can make your own modules. Package up your code so others can use it.
So we can be the coding experts, sharing our tools.
Exactly. That's how Python's grown so much. It's all about sharing and building on each other's work.
That's awesome. So modules are Lego bricks, but now we're building whole cities of code.
Love the analogy. And
It's-
speaking of building, let's talk algorithms.
Those are like the step-by-step instructions for solving problems, right?
Precisely. And ThinkPython walks you through the classics, like searching for something in a list or sorting things in order.
Searching and sorting, that's like data manipulation 101.
It is. But what's cool is there are lots of ways to do it, each with its own pros and cons for speed and efficiency.
So it's not just finding any solution, it's finding the best one.
Exactly. And ThinkPython is great at explaining the different approaches.
It's like a master chef teaching you different recipes, explaining why some work better than others.
You're getting it. And since we're talking organization, let's talk data structures.
Those are like the specialized containers, right?
Yep.
Lists, dictionaries, tuples, all that.
You got it. Picking the right one makes your code way better. ThinkPython breaks down each one's strengths and weaknesses.
We've hit lists, dictionaries, tuples, anything else.
Sets. Imagine those exclusive clubs. Only unique members allowed.
So no duplicates.
Nope. Sets are great for that. And Python has tons of tools for working with them. Adding, removing, checking who's in, even doing things like union and intersection.
Set operations. Sounds fancy.
Say you have two sets of numbers. Union is all the numbers from both, no repeats. Intersection is only the numbers that are in both.
It's like those Venn diagrams from school, but now we can actually manipulate them with Python.
Exactly. Sets are surprisingly useful, from filtering data to some pretty cool algorithms.
All right, sets are going on my list to learn. What else is there?
Well, we've covered a lot, but there's one more big thing ThinkPython is big on. Debugging.
Ah, yes. Bug hunting. We've talked about basic stuff like print statements, but is there anything more advanced?
Definitely. The main point is debugging isn't just about fixing errors. It's about understanding your code so well you prevent them in the first place.
So instead of being a bug exterminator, you're like a code architect, designing things to be bug-proof.
Love that. ThinkPython is all about thinking defensively, anticipating problems.
Like safety nets for our code in case we fall.
Exactly. One technique they talk about is assertions. These are statements that check if something is true. If not, they raise an exception, like a warning signal.
So instead of a crash, we're finding issues early on.
Yep. Assertions are like smoke detectors for your code. Early warning before things get out of control.
Brilliant analogy. Assertions, check.
Nice. And as you code more, you'll develop your own debugging style. The key is to be systematic, thoughtful. Use it to learn and make your code better.
Okay, so OOP, defensive programming, even fancy debugging. What's the big takeaway from ThinkPython?
I think it's this. Programming isn't just about code, it's about thinking a certain way. Breaking down problems, using logic and creativity to find elegant solutions.
It's like training your brain to think in algorithms and data structures.
Exactly. And those skills, they're useful everywhere. Not just coding, solving problems, designing things, even just navigating life.
So ThinkPython isn't just a programming book, it's a thinking book.
That's a great way to put it. And with that, I think we've covered a lot of ground in ThinkPython.
Wow, time flies when you're geeking out on Python. I can't believe we've covered so much. There's still more to explore though, right?
Oh, absolutely. In part 3, we'll dive into some of the more advanced stuff like object-oriented programming and, building code that's really robust and maintainable.
Sounds good. Looking forward to it. All right, part 3 of our ThinkPython deep dive. We've covered a ton from the basics to some pretty complex stuff. What's left on the menu?
Well, so far, it's mostly been about procedural programming. But ThinkPython also dips its toes into object-oriented programming, OOP for short.
OP, yeah. I've heard the term, but honestly, it always sounded kind of scary, haha. Is it as complicated as it seems?
It can be, at first. But the main idea is pretty straightforward. It's about organizing your code around objects, which are kind of like bundles of data and functions all representing one thing.
So instead of functions over here and data over there, we're putting them together.
Exactly. Like imagine Legos, but now each brick can have gears and stuff inside, and they can connect in more complex ways.
Okay, I can see how that'd be useful. How does ThinkPython explain it, though? Does it get super technical?
It starts with the basics, using examples that make sense, relating to everyday things. Like it talks about classes, which are like the blueprints for making objects, and methods, which are functions that are attached to specific objects.
So a class is like the recipe for a cake, and the methods are like the instructions for mixing, baking, frosting.
Perfect analogy.
Yeah.
And just like with cake, you can have variations. That's where inheritance comes in.
Inheritance, like passing down traits from parents to kids.
You got it. In OP, inheritance means you can make new W classes that get all the stuff from older ones. Super useful for reusing code and building on what you've already got.
So if cake is our class, we could have chocolate cake and cheesecake that get all the basic cake stuff, but also their own special things.
Precisely. And inheritance goes hand in hand with another biggie, polymorphism.
Polymorphism. Now that one sounds like a mouthful.
It just means different objects can react to the same command in different ways, like a universal remote that controls different devices.
So if we had a bake command, it'd do different things depending on if it's a chocolate cake or a cheesecake.
Yep. And polymorphism makes your code way more flexible. You can write code that works with lots of different objects without needing to know exactly what they are beforehand.
That's pretty powerful stuff. But sounds like there's a learning curve to get the hang of OP, right?
There is, but ThinkPython lays a good foundation. From there, you can dive deeper into fancier OOP stuff as you get more experience.
Okay. OOP is on my list to explore more. But before we wrap up with ThinkPython, gotta touch on debugging again. We've talked about the basics, but any more advanced tips from the book?
One big idea is debugging isn't just about fixing errors after they happen. It's about understanding your code so well that you prevent them in the first place.
So less like an exterminator, more like an architect, making sure the building won't fall down.
Exactly. ThinkPython is all about defensive coding, thinking ahead.
Like putting up guardrails so our code doesn't fall off a cliff.
Love that. One specific thing they mention is assertions, or like checks to make sure something is true. If not, bam, exception, warning signal.
So instead of a crash, we get an early warning.
Yep. Assertions are your code's smoke detectors. Let you know about problems early on before they get big.
Great analogy. Assertions. Definitely going to use those.
Good call. The more you code, the better you'll get at debugging. But always be systematic. Think things through. It's a chance to learn and make your code the best it can be.
All right, so OOP, defensive coding, even hardcore debugging. What's the final message, the core of ThinkPython?
I think it's this. Programming is more than just writing lines of code. It's a way of thinking. Breaking problems down, using logic and creativity to find elegant solutions.
It's training your brain to see the world in algorithms and data structures.
Absolutely. And those skills, they're useful everywhere, not just in coding. For solving problems, designing things, even just living your life,
ThinkPython, not just a programming book, but a life manual.
Aha, I like that. Well, I think that wraps up our deep dive into ThinkPython.
Wow, what a journey. I've learned so much. I'm honestly fired up to do more coding now. Thanks for being such a great guide.
It's been my pleasure. Remember, programming is all about learning and discovery. Keep exploring, experimenting, and most importantly, have fun with it.
And to all our listeners, if you're even a little curious about coding or just want to sharpen your brain, check out ThinkPython. It's a fantastic way to learn how to think like a computer scientist. Until next time, happy coding, everyone.